I was reading that today, and I didn't like the book. Yeah. I think just about instead of all the outreach. Yeah. I don't think it's a conversation about this, but I do a bit. Or should I bring my phone up?
Okay, hopefully everything's working online, and we've got a couple of attendees online today as well. So yeah, we'll start to kick off. Firstly, thanks everyone for coming. This is our, well, I think it's the 14th Early Career Award, top of my head. It's been going for a while. So just a bit of a background on the Early Career Network and who we are and what we do. So we were established in 2018, and we operate as a subgroup of the Geology Society of London. And our real focus is to provide early career professionals with a range of opportunities for networking, mentoring, and professional development all the way through from your sort of, whether you're academic studying in your undergraduate degrees, all the way through to chartership, really. And preferably, once you're chartered, you stay engaged as well, because we're working with the chartership office to really try and sort of network CJOL applicants with mentors as well. So one of our some of our key aims really is, and some of the things we offer is that we're a free membership. So we kind of present ourselves as a gateway membership to the GeolSoc and the main GeolSoc. We're again quite accessible in that, and what we're trying to do is really promote early career people with getting engaged with the society and the wider society. As part of that, we're really driving collaboration across different groups, whether that's internal and external to the GeolSoc. You'll see some of our goings on later on during our AGM. And really what we're trying to do here is promote geoscience industries in general, and really inclusivity across the whole industry. So our network's managed by a volunteer committee of GSL fellows. We've got experience ranging from chartered professionals all the way through to undergraduate students. And we quite impressively market ourselves across pretty much every geoscience industry. So yeah, we're quite a good group for that. We do have a mailing list, so if you're not already signed up, please sign yourselves up so you can keep in contact with what we're doing. There is a QR code up there, and these slides will be recorded and presented online as well. So in terms of the award itself, it's a science communication award, and the key word there is communication. Finalists are nominated by the local regional groups. So everyone here, all of our finalists are from various different regional groups across the UK, and each of them have hosted their own local competitions throughout the year. Each candidate will be presenting a 10-minute presentation on a topic of their choice. And the key thing is that the marks are really weighted towards communicating a science topic to a industry-wide early career geoscience audience. As such, much of the weighting is on presentation, so that's delivery and clarity of the message. legibility of the content that's being presented, and creativity in how you're presenting it. There is also marks awarded for technical content and your understanding of that content, and the accessibility overall of the presentation. Usually there would be a Q&A, but due to the very good turnout of finalists this year, we are taking that off this year. So what we will ask instead is that the judges all provide some constructive feedback to each of the applicants, and then we can pass this on following the event. We're also going to a sort of an after event social as well. So if any of the finalists are there and want to have discussions and ask questions, then please do in a sort of nice social environment. In terms of the awards, so the winner of this award today will take home our early career trophy, which is hidden somewhere. There it is. So we've got a nice block of Fuchsite here today. Very, very well done. I think Simon helped to procure that again. And the winner will also receive a £100 voucher, and all of our finalists automatically win a 1-year fellowship with the JobSoc as well. So yeah, that's excellent. So to introduce our judges, I'd like to ask each of them to come up and just do a very brief introduction of themselves, starting with Jonathan.
Hi, good evening. Yeah, my name's John Parry. I'm a technical director from Cieslak Consulting. I'm a hydrogeologist by training, specialising in contaminated land. I'm a former regional group chair, so I was chair of the Western Regional Group for 5 years. I have previously been a judge in a regional early careers award, and also hosted a regional round, but back in the day. So I'm really pleased that I've been invited back. And that you know, the awards are still going strong. SLR are sponsoring the event tonight because we really support early careers geoscientists, and we're an employer of probably over 150 geoscientists in the UK. So we really support the idea of this, and yeah, looking forward to seeing the presentations. Thank you.
John.
Good evening, ladies and gentlemen. I'm John Lewis and have the privilege at the moment of being the current president of the Geological Society. You might notice I'm not early career, though I'm very pleased that Dan has managed to find a photograph taken in 2005 to show me slightly younger. I didn't have the opportunity for an early career network when I began. It came out of university and started in industry. I could have done with one. We were somewhat isolated in Aberdeen, as it happens. And so the opportunity you have here to converse and understand and develop yourselves through this group is superb. Enjoy the evening and good luck.
Hello, good evening. Can you hear me? Sorry, I'm a bit further away from the microphone. I'm Dipali Dukes. I am co-founder and CEO of Ground and Water. Ground and Water is a geotechnical and environmental engineering consultancy, bit of a mouthful. We deal with geotechnical site investigations, we do a lot of contaminated land, risk assessments, working on brownfield, redevelopments all across the south of England. I'm a geologist by study and a geotechnical engineer by trade. And what else can I tell you? I've been in the industry 22 years, and Ground and Water has been going for almost 16 of those years. And we are a team of 20, and we're always looking for budding geoscientists and geotechnical engineers to come and join us. So do check us out. And outside of the workplace, I also do a lot of outreach work in the industry, in education, and I've got a podcast called Shy and Chat Engineering, where we get female ethnic minority engineers in the industry to come and talk about their backstories, their challenges, and their journeys and successes to inspire next gen. So if you want to have a little listen, please check out Chai and Chat as well. And yeah, really excited. Dan invited me to come and judge. So yeah, looking forward to this evening. Thank you.
So on to the competition. So our first presenter unfortunately can't be here today, presenting from Hong Kong. So we've got a pre-recorded talk for this one. Following that, we'll have Emma. I'm not going to try and pronounce her name, I will get it wrong. From East Anglia Regional Group, followed by Amy from the Southwest. I believe Amy is also tuning in online tonight. David Whitworth from Thames Valley, who last minute has also had to tune in online. Elias, I think he's in here somewhere. Wave, there you are. From Home Counties North. Seb Rowe from the West Midlands. In the middle, nice one. We've got Nicole Armstrong from Northwest, who I believe is also tuning in online this evening. And finally, Chris Freeman from the Southeast Group. So yeah, without further ado, we'll change to our first talk from Calvin.
Good afternoon, everyone. I'm Wong Chan. Today, I'm here to present my final year project, Offshore Buried Paleochannels and their influence on groundwater and seawater exchange. In this presentation, I will first give a brief introduction on this project, then talk about the material and method I used, and discuss the results generated using such methods. So, what are paleochannels? Paleochannels are radic fluvial channels that infilled with sediments that are more permeable than the surrounding matrix, like gravel surrounded by fine sand. For the Perl River estuary, it is located in the South China Sea, which is a passive continental margin. Because of the sea level changes, a series of regression and transgressions occurred, forming an interbedded aquifer-aqueduct system. So when the sea level was low, the continental shelf was exposed and created spaces for fluvial incision. When the sea level rises again, such incised channels will be filled with inner shelf sediment, forming the paleochannels. So why do we need to study such paleochannels? This is because paleochannels have the potential to store lots of fresh groundwater because of their hydraulic properties, but it is also reported that they can foster seawater intrusion in some places. Hence, it is important to truly understand the role of paleochannels in the seawater-groundwater exchange process in order to safeguard these potential water resources. However, only limited research have been done to characterize the hydraulic and geometric properties of these channels. And hence, the objective of this research are to study the hydraulic and geometric properties of the paleochannels and perform a numerical modeling using the acquired properties to study how the paleochannels affect the interaction of groundwater and seawater. For the material used in this project, we mainly use two types of data, which are the offshore borehole data and the sub-bottom seismic profiles. They are obtained from different offshore drilling missions and geophysical survey missions listed here. And this map shows the location of the used data. And here are some photos showing the samples from the 3 boreholes and the drilling ship. In order to get the hydraulic properties, we performed particle size analysis using the borehole data. The location of the 3 boreholes were chosen based on the previous seismic reflection survey. The boreholes that successfully retrieved the marine core samples at the paleochannels was LD21. After getting the samples, we used different methods to do the particle size analysis based on the sediment size of the samples. For sediment larger than 0.075 millimeters, we will do the sieve analysis, while for the sediment smaller than the 0.075 millimeters, which is the silt and clay, we will use laser diffraction analysis. And here showing the procedures of doing the sieve analysis, and we used a set of ASTM standard sieves. For the laser diffraction analysis, the procedures are more complicated, as impurities must be removed before entering into the machine in order to increase the accuracy of the result. After doing the particle size analysis, we can generate the particle size distribution curves. Using such curve, we can get the D10 and D60 or D60 values of each samples. Then we can use the equation shown here to calculate the hydraulic conductivity and porosity. By plotting a hydraulic conductivity against depth profile of the 3 boreholes, we can clearly see some spikes in the data. By correlating them to the stratigraphic columns, we know that the hydraulic conductivity for the gravelly sediment in the paleochannels is 1.25 times 10 to the powers of -2, which is much larger than the hydraulic conductivity of other sediments by several magnitudes. The porosity of the for the paleochannels is also calculated to be 42%. For the geometric properties, we use seismic profile interpretation to acquire such parameters and the distribution of paleochannels. First, we extract all useful seismic profiles from the data source and find the U-shaped and V-shaped channel based on the unconformable truncated surface. Then we record their location using GIS and measure the geometric properties using slice methods. We found that based on the reconstructed paleochannel distribution map, the paleochannels can extend out to 60 kilometers into the South China Sea, showing the spatial extent of the paleochannels is quite large. We also use a depth against distance profile showcasing the morphology of the paleochannels from all interpreted seismic profiles. Different summary statistics are used to summarize the geometric properties of the paleochannels and found that the average cross-sectional area can be up to around 27,000 meters square. But in the hopes of selecting the most representative depth and width of the paleochannel for doing the numerical modeling, histogram is used and found that the mode of depth is 50.05 meters, while the mode of width is 1.55 kilometers. After acquiring the hydraulic and geometric properties, we can use the parameter to do the numerical modeling to simulate the interaction between seawater and groundwater in the paleochannels. For the conceptual model, we conceptualize the ground condition into 4 layers and 3 hydrogeological domains, which are the aquifer representing the marine deposits as the top layer, paleochannel as the second layer. Aquifer formed from terrestrial alluvial unit, and the last aquifer layer formed from the completely decomposed granite. And this showed how we acquired the elevation data to form the topography of the model. The 3D model showed the domain of this model is 5 kilometers in width, 27 kilometers in length, and 105 meters in height. The shoreline separates the seawater and groundwater boundaries. And here show the parameter set for the initial condition and boundary condition of the numerical model. For the governing equations, we used these 3D finite difference codes to calculate the groundwater flow and solid transport in a density-dependent flow setting. For the result, from this simulated salinity profiles at different cross-sections, we can see the presence of paleochannels change the dynamics between seawater and groundwater. From the cross-section, cross-cutting the channel axis, which is the section 1, and the channel flank, which is the section 2. The mixing zone extends seaward with paleochannels. And when we view the results in a bird eye view, we can see that in the paleochannel layer, which is the section 4, the seawater intrusion and groundwater discharge occurred at the same time, but in different places. Seawater intrude along the channel axis, while submarine groundwater discharge along the channel flanks. So in conclusion, the results in this research project showed high hydraulic conductivity in the paleochannels, and such aquifer with a large cross-sectional area will hugely affect the flow path of groundwater in offshore region, and this in turn affect the dynamics between seawater and groundwater. Normal mixing zone of seawater and groundwater should initiate near the coast and extend landward, but the presence of paleochannels shift the mixing zone seaward. Also, it is found that the paleochannels serve as a perennial channel for both seawater intrusion and groundwater discharge. By understanding the role of paleochannels in groundwater and seawater exchange can increase our understanding of offshore hydrogeology and be beneficial for future exploring such valuable groundwater resource. There are some limitations for this project, such as limited seismic profile will hinder the resolution of the reconstructed map. And also, I would like to take this chance to thank you for my for the mentoring and guidance provided by my supervisor, Professor Zhang. And this is the end of my presentation. Thank you.
Okay, I'll come back to my slides. I think we'll have the next presentation coming shortly. That's not working. I think it was Emma next, top of my head. Oh, there we go. Wonderful. Yeah, next presenter is Emma.
Put that there. I'll try my best to stick to the time. Okay. Ah, perfect. Thank you. So my talk today is going to be on the Great Pyramids of Northern France. Now, I'm sure you're all thinking, what on earth is she talking about? I hope by the end of this presentation, it will make a lot more sense on the slight play on words that I've used here, but I won't ruin it right at the start. So my name's Emma Cieslak-Jones. I'm currently a second-year PhD student studying at the University of Lille in northern France. So I'm here representing the East Anglian Geological Group, as I'm based between London and Lille, 50-50 sort of thing. I'm also the creator of the geological blog NGEMS, which I run on YouTube and Instagram. So I try and create as much educational content as I can surrounding geosciences. How do I go now? Oh, there. Oh. Okay, so I'm going to be talking about northern France. So it's called the Hauts-de-France region. So France is split into 13 of these. And within the region, there's 5 departments. Now, the departments of interest for me are the Nord and the Pas de Calais. So here's another map. I do like maps. So the Nord and Pas de Calais, you can see we've got, is there a laser? Aha. So we've got a mining basin here, which is the Nord Pas de Calais mining basin, and also the Boulonnais mining basin there. So this is a very quick summary to just kind of set the scene. So there are some key facts that I would like to share with you all. So the Nord Pas de Calais area has seen 3 centuries of coal mining that date all the way back to the early 18th century. This coal mining activity ceased in the early 1990s, which led to an economic decline. So there was a lot of unemployment, a lot of poverty, because for 300 years, that's all the area knew. So all the infrastructure, generation after generation, it's all they did. So it needed another purpose in order to revive the area. And so 22 years later, after the last piece of coal was mined, it was inscribed on the UNESCO World Heritage List in 2012, which gave it a new purpose. And it was inscribed for its cultural heritage. Now, the question I'd like to address today, what about the natural heritage? So as per UNESCO, heritage, our world heritage is classified into 2 main categories: cultural heritage and natural heritage. And when it comes to industrial heritage, so things like mining areas, it gets classified within the cultural heritage banner. But when it comes to geoheritage, so all things geology, so rocks, minerals, fossils, soils, biodiversity as well, it goes into the natural heritage banner. But mining activity there's a connection there between both natural and cultural heritage, and it's the combination of the two that actually leads to these sorts of areas. So this is part of what my research is focusing on. So this is present day northern France. So these big piles, they go by many names. So they're called terrals in northern France, but they're basically slag heaps. They're waste piles. And these waste piles, they can be seen from miles away. They're big black mountains, you know, they're very kind of substantial, and there's hundreds of them. And these are a result of the mining activity. So you even get pairs of them. So this is a flat area otherwise, but the mining activity has caused this almost mountains to be formed. And you can see here the infrastructure is built around the mines. So you've got all the houses looking in certain directions, you've got the shafts here, and then you've got these amazing heaps. And the interesting about these slag heaps is since the inscription on the World Heritage List, they've got a lot of infrastructure. So they've put paths on them, they've become recreational spaces, and even some of them have been turned into, we've got a ski slope, we've got some that have a swimming pool at the top. They're encouraged for locals and also tourists to run on them, cycle on them, use them and enjoy them. They're not negative at all, there's no negative perception around them, but that's not always been the case. So if I take you back in time now to when these slag heaps were being produced, you can see there's a lot more slag heaps there than what exists today. And that's because when the mining activity stopped and the economy plummeted, unemployment and poverty was rife, they wanted to kind of erase that history because it wasn't a legacy they were proud of. They didn't want to, you know, remember the coal mining because now it was a constant reminder of what they once had and also the damage to the environment. And so a lot of these slag heaps got erased, some of them necessary for safety reasons, but it was a very different perception. And this is something that is still today, the public's perception on mining is a very sensitive topic, and it's very easily swayed depending on, you know, how the media takes it. You know, bad examples carry a lot more weight than positive examples. And in terms of mining heritage, they focus on the cultural links to the humans. But what about the natural connections and the geological connections? So for those of us less familiar, I'm going to do a really quick summary here on how coal is formed. So here I've taken you back to the Carboniferous period, which is what geologists call a period that occurred 300 million years ago. And it was very tropical, swampy. You can see lots and lots of trees and plants and even insects. And these trees and plants, they have a finite life, and these would fall into the boggy, sort of swampy area here. And over time, what would happen is it accumulates. And this accumulation of organic material over time becomes peat. And then if you mix that with a lot of time, heat and pressure, and more layers go on top of it, it gets condensed into a coal band. And then the final step is uplift and erosion, and you might even get that coal band exposed. Now, when it comes to coal, you don't just get one type of coal. It's not as simple as tree falls into swamp, over time forms coal. You actually get 4 different types of coal, and they have different grades, and they also have different uses. So the higher the grade, the more useful it is in the metal industry, and the lower the grade, it's probably used in kind of generating electricity. But you don't just get coal. So it's formed by plants and trees, and you also get some of them preserved as fossils. So in Nord-Pas-de-Calais, during the 3 centuries of coal mining, they also collected over 100,000 incredible paleobotany specimens that are then stored in the University of Lille and also the surrounding museums. Now, these specimens, they've been, you know, curated all this time, and they're in public collections, but because people don't know about them, there's limited access. You know, that we've got incredible specimens that whenever they are studied, so this is my colleague here, Athucina, who is studying some of the plant fossils that have come out of Nord-Pas-de-Calais, and a lot of them go on to become type and figured specimens because they're really, really key to science, but so many of them are hidden away. And by giving an area just a label for its cultural heritage, a lot of the geo-heritage is forgotten and left behind, especially if it's in the basement of a university, which is unfortunately the case here. But it's not just geodiversity, we also get incredible biodiversity as a secondary to the mining activity. So these slag heaps, produce their own almost mini ecosystem. So they're a lot hotter than the surrounding area, which means they attract their own species. So plant species and animal species. And so we get the European nightjar, and we also get the natterjack toad, which is one of my favorites because its mating call can be heard over a mile away from where it's mating it. So really trying to keep his options open. So with a 1 mile radius, which I think is quite impressive. So to conclude, I want to bring us back to that very first slide of the Great Pyramids of Northern France and trying to make sense of that. Now, the reason I made that link is because both the Nord-Pas-de-Calais slag heaps and the Great Pyramids of Giza are inscribed on the UNESCO World Heritage List for their cultural heritage. So they technically have the same designation as each other. And there's some other similarities as well. They do kind of have a similar shape, but I understand that that is quite different. But they both have a link to geoheritage in terms of their formation. They're both entirely made of geoheritage, pretty much. They thrive from tourism, and they are a huge part of our human history that shouldn't be erased. So I think these sorts of areas, it's really important to ensure that there's lots of different types of heritages there, and we should embrace all of them, especially the natural heritage. And I may be biased, but I think the geoheritage, in terms of mining, definitely has a leg to stand on and should be represented. But thank you for watching. I think I waffled a bit faster than I was planning to there, so I think I've got 1 minute to spare. But yeah, I hope you enjoyed, and any questions, feel free to find me afterwards in the networking. And these are ongoing results as part of my PhD project. So thank you to the University of Lille and also the East Anglian group for giving me the opportunity. So thank you very much.
Hey, I believe our next presenter is coming from online, so hopefully Amy is tuned in and we'll be able to talk over this in a minute.
Hello, can you hear me all right?
We can. Hi, Amy.
Great. Hi. I shall share my slides.
I have them for you, if not.
Okay, thank you. 1 moment. I'm just struggling here a minute, sorry.
Okay, take your time.
Share, there we go. Can everybody see that? Yep. Okay, great. Right, so hello everybody. My name's Amy and I'm a research assistant on the EXCESS project looking at global landslide susceptibility. As a brief overview of what I'm going to cover, I'm going to look at why landslides are so important to study before diving into my role within the EXCESS project. So landslides, these are the movement of a mass of rock, earth, or debris down a slope. They have two main natural triggers, earthquakes and rainfall. And from these, the different mechanisms involved, they create different types. So they can have different amounts of water involved, different materials, and they move at different velocities. As a result, they occur across the entire globe, as almost every country experiences one of these triggering factors, alongside anthropogenic influences like road building and deforestation. They're extremely dangerous hazards, and they kill thousands of people each year and cause billions of dollars of infrastructural damage worldwide. We can try to spatially quantify these risks through creating inventories. You can use satellite imagery as it's fast, easy, and cheap to use. And this can also be supplemented by fieldwork and site assessments. As a bit of background to the current project, research was carried out by Josh Jones in 2021. and they created a 30-year multi-temporal landslide inventory from Nepal. They were investigating peak ground acceleration and excess topography. Now, excess topography is the area above the threshold slope. So it's demonstrated on this image on the slide here. And they found that these two factors interacted and produced areas of higher landslide susceptibility. You can see this on the graph on the right of the slide, where following a blue star at the bottom, which shows different earthquakes. This blue star, the latest one in 2015, represents the Gorka earthquake. And following this, the background rate of landsliding was highly elevated, as you can see outside the dashed lines, the elevated landsliding rate. This was the foundation for the Excess project, and my role within this is to create rainfall-induced multi-temporal landslide inventories, and this represents the background landsliding rate. I will be doing this in 6 case study regions around the world, and each of these regions has been chosen as they experienced an earthquake of varying magnitudes, and they will have different geologies and climates. Following mapping that I'm going to do, analyses will include magnitude frequency plots and control factor analyses to focusing on peak ground acceleration and excess topography. The end goal of this project is to create susceptibility assessments, which can then be fed back to local communities and aid organisations. The 6 case study regions are highlighted on this map as 6 red pins. And the first location I'm going to talk about, which is the first one we've started on, is Papua New Guinea. Now, Papua New Guinea is highly tectonically active, as you can see from this figure on the slide. It's located at the boundary zone between the Australian and Pacific plates, and the collision between these 2 plates has created an uplifting mountain chain, and the Papuan fold and thrust belts, which you can see in the centre of the image here as the light brown white area. Our study area, which is shown by the blue oval, is located within this zone, and the red explosion symbol shows the location of the earthquake. This occurred on the 25th of February 2018 and had a moment magnitude of 7.5. It was followed by 4 aftershocks and occurred within the wet season, which is thought to have exacerbated the landsliding rates. So as a result, it caused 11,000 co-seismic landslides. So following selection of our first case study region, my role within this project was to collect data of variables that we know influence landslide susceptibility. So I downloaded a digital elevation model and derived various factors, including slope, aspect, relief, as well as obtaining geology and soil. As you can see on this slide here, the most common lithology is limestones and mudstones, and there's variable tropical soils with a highlight of red and yellow latisols, represented by the yellow colour. There's the topographic relief was used to create excess topography. And so that is on the right panel at the top. And the black polygons represent the co-seismic inventory that has been created. Following collection of each of the variables, I then downloaded satellite imagery data. We chose Planet Labs data, which has got a resolution of 5 meters, over other imagery sources such as Landsat or Sentinel-2. Following download of the data, you can then manipulate band ratios to create false color composites. Now, these involve a replacement of the red band with the near infrared band and replaces the appearance of green vegetation with red vegetation. So as you can see here, this is what they appear like. And this is taken from 2017, which is before the earthquake. This image here was taken in 2018, so directly after the earthquake, and you can see the extent of the landslides which have occurred, which is really cool. So the false colour composites aid in the identification of landslides here, and once you've identified them, you can draw polygons around them and detail associated attributes in mapping software such as ArcGIS or QGIS. This was the process undertaken by Hakan Tanyas, who created the co-seismic inventory for 2018 following this earthquake event, which is what is shown on the slide here by the black polygons around each of the landslides. This is the process that I have carried out to create the rainfall-induced multi-temporal landslide inventory, which you can see here, the progress so far. 2016 and 2017 are our first two pre-seismic years. 2018, the centre here is the co-seismic inventory, and 2019 and 2020 are the two post-seismic years so far. The timeline at the top of the slide here shows plans to continue this for 2021 and 2022, which will then conclude the Papua New Guinea field site location. I've been focusing on mapping the inventory so far, so haven't been able to undertake deep analysis of the results so far. However, preliminary analyses of the pre-seismic years include a probability density plot. This is 2016, and you can see the probability density plot on the left side of the graph here. On the y-axis, it shows probability density, and on the x-axis here, it shows area. So you can see by the curve here, it's got narrowing of the quantile bands, which shows the data is quite concise and accurate. And the low rollover curve of 513 is actually thought to be a function of the high resolution of the imagery. So as some final remarks, landslides are extremely dangerous and they do need to be managed. Spatial quantification through the creation of inventories is what the Access project is trying to do in 6 sites around the world. These 6 sites have varying earthquake magnitudes, geologies, and climates to try and encompass all variable environments which we can model. And the end product, which will be a susceptibility assessment, will be fed back to local communities and aid organisations. Thank you very much for this. It's my end of my presentation. I will stop sharing. There we go.
Thanks, Amy. That was excellent. All right, John. It's all good. You've got 30 seconds. That's a good sign. Okay, might as well keep going. So our next presenter, I think, is Elias. Sorry if I got that wrong. If I got that right.
Don't know why half my slides off there, but anyhow, some amazing talks so far. So yeah, thanks for including me in this great event. I'm Elias and I'm a PhD student at University College London, and I'm going to present some of the work that I've been doing throughout my PhD. In particular, I'm going to be focusing on the lovely image that's shining in the background there. Would you believe it? That is Costa del, Scotland. And in particular, it's a place called the Garvellach Islands. And the reason I want to talk to you about them today is that I believe that through my work and lots of work of people before me, we have found an extremely rare record of what's known as Snowball Earth. So what is Snowball Earth? Well, Earth has 3 main climate states. We have a greenhouse Earth, where we have no ice on land or at the poles. We have an icehouse Earth, which is what we're in today, where we have ice at the poles and ice on land. And Earth fluctuates between these two at reasonably regular intervals. And that's because Earth has these beautiful feedback mechanisms which prevent it becoming too hot or too cold, which is why this third climate state is a little bit odd. That's the snowball Earth. And this is a climate state where ice extended all the way from the poles to the equator. And it's extremely rare. It's only happened 2 to 3 times in Earth history. In fact, we have to go all the way back to the Neoproterozoic, and in particular, the Cryogenian, some 635 million years ago, before we see our last snowball Earth. So the Cryogenian period, and it's an extremely interesting period because it has these 2 snowball Earth intervals in them. And people that study them, they're asking themselves these questions: who, what, where, when, why? So what are we looking at? It wouldn't be a geology presentation without some pictures of rocks. These are glacial rocks. They're tillites. They're formed at the base of glaciers when glaciers plough through the landscape and pluck rocks up and then deposit them when they eventually melt. So that's what we're looking at. When did this occur? Well, as I mentioned, there's 2 snowball Earth intervals during the Cryogenian. There's the older Sturtian interval, which lasted from around 717 million years to around 660 million years. And then there's the younger Marinoan interval, which lasted from around 645 to around 635 million years ago. And it's important, I will mention, I will come back to this later on in the presentation, so it's important to note there are 2 discrete intervals of snowball Earth. So where do we have these deposits? Well, they're everywhere. We have them on all 5 continents, and that attests to the global nature of the snowball Earth. But it's this final question of why and how that I'm interested in. How did we get ourselves into such an enigmatic, rare climate state? And it was early on in my PhD that I unfortunately encountered a problem. Glaciers are extremely erosive agents. They plough through nearly everything you see in sight. You only have to go to a recently glaciated environment to see this. And this is no exception for the snowball Earths. We can see just by looking at these, they've ripped nearly all the rock from beneath them and transported it and deposited it elsewhere. Here on the right is one of my favourite outcrops. It's on the Garvellach. It's a massive 40-metre block of carbonate by 100-metre wide that's been plucked up by a glacier and transported and then deposited. So they're incredibly erosive agents, which is a real nightmare for geologists, as the record between the Tonian and Cryogenian has pretty much been removed everywhere globally. Until now. I'm going to take you on a little field trip to where I've spent a lot of my PhD to show you where we believe we have a rare exception to this erosional phenomena. We're looking at the Garvellachs, which are a small chain of uninhabited islands off the west coast of Scotland. They're an amazing place to do field work and an extremely beautiful place if you ever get to go and visit. This is what they look like on a geological map. I'm going to do some PowerPoint wizardry now and spin this round and zoom in. And this is what they look like as a geological map with everything younging upwards. In orange, we have the rocks of the Port Escape Formation, which represent the snowball Earth interval. These are the glacial rocks. But it's on that far left of the diagram in that square, which is what makes the Garvellachs particularly unique globally. That's the underlying rocks, the Garvellach Formation, which are carbonates. So the Port Escape Formation, I'll go through this quickly. Amazing, diverse record of snowball Earth glaciation. They look a little bit like this in the rock record. They're exposed all across Ireland and Scotland. And for a 700 million year old glaciation, if you look at the modern analogues to what we see preserved in the rock record, I think that's pretty amazing. But as I mentioned, it's the Garvellach Formation. It's what's beneath them that I'm interested in. That's the contact between the Garvellach Formation and the Port Escape Formation. It's 75 metres of exposed carbonate beneath the Port Escape Formation, and we believe we can argue that we have continuous sedimentation into the Port Escape Formation without that erosional phenomena we see everywhere else on Earth. So this is what it looks like stratigraphically. We have 3 facies here, some limestones to start off with, then some siltstones, and then some dolomites. And these dolomites, we start to see what we argue to be early signs of ice. And this attests to this gradational onset of cold conditions. So at the very base of the Garvellach Formation, we have stromatolites. These are algal mats that form in warm tropical seas, which is amazing. 70 metres below unambiguous glacial sediments, we have signs of a tropical environment, which is unsurprising as Scotland was situated at the equator at this time. But then we move up to where we see these early signs of ice. we see these things called drop stones. These have been transported, rafted by ice, and when the ice has melted, they've been dropped into the sediment below. We see these emergence horizons that have cracked under periglacial conditions. We see gypsum pseudomorphs. Gypsum is a mineral that forms in an arid environment. The most arid environment on Earth today is Antarctica. And that's before we get the Portishead Formation, these unambiguous glacial rocks. So we have this amazing record of Earth's descent into Snowball Earth. But we have a problem in Scotland. We don't know how old these rocks are. The current constraints on the larger package of rock that the Portishead Formation sits in, we have this 840 million year maximum depositional constraint up there, and we have a 600 million year minimum constraint there. In between, we have 25 kilometres of stratigraphy that we don't have a clue how old is. That's where the Portishead Formation sits. As I mentioned, we have two discrete Snowball Earth intervals. We only have one package of glacial rocks. So that means that the Portishead Formation could either be the Sturtium or it could be the Maranoan. We have no ash beds, no fossils, no igneous bodies. What do we do? Well, for my PhD, I took 11 samples of sandstones from throughout the Portishead Formation. I extracted the mineral zircon from each sample, and then I measured the uranium-lead isotope composition on a laser ablation mass spectrometer. Why did I do this? Well, zircons are amazing little minerals. When they form in magma chambers, when they crystallize, they incorporate uranium, and over time, that uranium decays to lead at a known rate. And from that, we can work out the age of that mineral. But we're not looking at a magma chamber. We're not looking at an igneous rock. However, we can use this rule that a sandstone can't be older than its youngest grain. And that's what makes these next results quite remarkable. I found 8 zircons that fall within the range of the Sturtian glaciation. We found no zircons from around 2000 that were younger than the Sturtian glaciation. No zircons from below the Portishead Formation that were younger than the accepted glacial onset. The uppermost sample that's taken from just after the final glacial sample agrees with other constraints for deglaciation, and we see this amazing younging up trend. So if you combine that sedimentological evidence of a unique global transition with these new geological constraints, we have perhaps the most complete record of Snowball Earth known on Earth. So just to recap, that means we've got the Garvellach Formation in the latest Tonian and the Portishead Formation in the Cryogenian. I published these results in the Journal of the Geological Society, and it's fair to say that I wasn't the only one that was excited by them. But what is the big deal? Well, we have to go back to our geological timescale, and in particular, the Cryogenian. And you may notice at the base of each period, you see those golden spikes. They're GSSPs. They define the archetypal section globally. There's one place it's placed at, which is the archetypal section globally, which represents the transition from one geological period into the next. There isn't one yet for the Cryogenian. The new age constraints that I found out, along with the sedimentological evidence, now places the Garvellachs as a leading candidate for the basal Cryogenian GSSP. The last one that was ratified was 30 years ago, and that was the basal Ediacaran. I've led 2 groups of the Cryogenian subcommission to the islands over the last 2 years, and the vote is going to happen at the end of this year, hopefully. But also the question of why and how. And for this, we need to talk about rocks. Geologists need rocks to test their models and hypotheses about how we ended up in this enigmatic climate state. And now, hopefully, conclusively, we can say that we have preserved on the Garvellachs a record transitioning from the Tonian into the Cryogenian without any breaks. Thank you very much.
Okay. I've lost the running order, so I'm sorry, I've lost track of where we are. Sure, the next slide's coming. There we go. Sebastian Rowe. Seb, you ready? That's all.
Hi everyone, my name is Sebastian Rowe. I am a marine geoscientist at Atkins Realis, an engineering consultancy firm where I specialise in offshore geology, particularly for offshore wind farms. My day-to-day is working out the ground conditions at these sites to reduce the risk and subsequently the costs. If I could get 10 minutes of your time today, I'd like to talk to you about a project close to me, a ground model project for a floating offshore wind farm in the Moray Firth, Scotland, a region characterised by complex glacial processes. Unfortunately, I can't disclose the exact location of the site, but I hope you agree with me that ground variability poses a significant risk to these structures, and is how we communicate that with engineers as geologists, is how we can overcome them. Before I introduce you to the site, the ground investigation, the ground model undertaken, and how we communicated those risks, I'd like to share with you a quote from the famous Victorian polymath and author John Ruskin. The common law of business balance prohibits paying a little and getting a lot. It can't be done. Not only does this show John's frustration at the lack of funding at the time, but it today emphasised the need to recommend the right course of action, pay the right amount of money, and get the desired outcomes. A significant failure of the US offshore wind farms was underestimating this factor. It's now our role as geologists to recommend the right course of action and not underestimate the risks at our sites. The site itself is a 1 gigawatt floating offshore wind farm. It's proposed to have 60 megawatt turbines, which is a huge undertaking when you consider that the current commercial floating offshore wind farm just south of our site has 5-6 megawatt turbines. Give you an idea of scale, a 60 megawatt turbine is the same size as a shard. And that's just at the top. It's not including the moorings, chains, and foundations that can go up to 50 to 100 meter water depths. A huge structure is what we're dealing with here. The site itself, northeast of Scotland, northeast of Aberdeen, about 80 kilometers offshore, is part of the round 4 offshore wind farm sites that help the UK government reach its net zero goal of about 50 gigawatts. I had the fortunate opportunity to go offshore a year or two ago now to supervise the ground investigation that the team and I designed. This boat was my home for 6 weeks in the middle of the North Sea. If you're not familiar with the North Sea, you can have waves as small as 1 meter to as towards 10 meters. Thankfully, the largest wave we dealt with was about 5 meters, but this can be quite choppy when you're dealing with this piece of equipment called the Rosen Mark 1 in green, the cone penetration test, and we have to get that 100 meters beneath our feet onto the seabed. And then within 1 meter accuracy, and then we have to bring it back up. It weighs about 12 tons, it's about 3 meters tall, 2 meters wide, and it's swinging about, and you're there trying to bring it back onto the boat with a piece of rope. That being said, I do recommend going offshore. You got 3 meals a day, sauna, gym. I promise you we do work. But what did we actually do? What data did we use for our ground model? I first did a desktop study to work out using published geological maps, investigate what the initial ground conditions were to understand what surveys we should be doing for ground investigation. For geophysics, we use side-scan sonar and multi-beam echo sounder for the image of seabed, sub-bottom profiler and ultra-high resolution seismic for the subsea bed, essentially shooting sound into the ground, and based on a response time, based on how it travels through the sediments, we can get these lovely black and white images on my right here. To ground truth this, we did about 140 vibrocores, essentially shaking a pipe into the ground. And you can see some lovely pelagic sediments on the top on the left, pink glacial lacustrine sediments, lake sediments, and then glacial tills, boulder clays, glacial deposits, and clays and gravels at the bottom there. To complement this, we did cone penetration tests, our continuous data parameters using cone resistance, leaf friction, pore water pressure, which gives us an idea of the strength of the soil. Give you an idea of costs, it's about £40,000 a day, $1 million in 4 weeks. So you need to get it right first time, otherwise you're going to be running out of money. I won't say no to going offshore again. But the regional framework, all this data means nothing if we don't know the story of how it's got there in the first place. Evans and his team did a preliminary investigation across a lot of the North Sea and identified in the Moray Firth multiple channels, basins, valleys in our area. These were created during the last glaciation age, which was Glacial, 115 to 11.7 thousand years ago, which essentially ice sheet is irradiated from Scotland eastwards into our site. And it's a reason for what we see on our seabed today. This is an example of the multi-beam echo sounder data of the seabed. Imagine the seabed about 100 meters depth without the water on top. Can't see so much, so let's up the vertical exaggeration. And this, what we can see here is a huge archaic feature, radial feature, and that's a terminal moraine. It's part of essentially the greatest advancement of that ice sheet as it's scraped across the seabed and then melted away, and that's what's been left in its wake. What we see in between there are recessional moraines. Essentially every winter it's advanced, every summer it's melted back. As the ice age wane, it's then retreated back into Scotland. That's what we're seeing there. And to give credibility to this, we can use onshore analogues. This is the Muller Glacier in New Zealand near Mount Cook. And again, you see those sort of radial archaic shapes and those recession moraines, and gives us an idea of what conditions we might be expecting in our area, but also that what we're seeing, what I'm telling you is somewhat correct, and what might be causing that. But that's just a seabed. With a floating ground model, we need to be looking at 50 meters below the seabed. And there's been two other glaciation phases we need to be dealing with. The Salian 250,000 years ago, the Estuary 480,000 years ago. They essentially sculpted the landscape, creating channels and valleys based on the rise and fall of the sea levels. This is an example of that high resolution seismic. And you can see every black and white line, a different sort of sediment layer that we're dealing with here. In the middle, in the red, there's a tunnel valley, similar to the Norwegian fjords of Norway, a kilometer wide, 200 meters deep, and it's now infilled with sediment. Got paleo channels where the glacier meltwater has actually eroded the original sediment behind that. All that information means nothing to the engineers. We don't give them some context to that and find out what's important to them. We can use engineering ground units, expecting based on the sediment type, the strength. We can see here in EG11 or ground engineering unit 11, a bedrock overlain by EGU10, which is a tough till, and then weaker sediments as we go above. This helps us to determine what foundation types we might actually use for our turbines. So this is where it comes to the design-led ground model, a 3D classification of the ground conditions. Essentially using a cone penetration test, we can identify those engineering ground units based on the strength of the soil. A key one of importance is EGU8B. It's a high-strength, over-consolidated till where the ice sheet is actually compacted to the sand. The cheapest foundation we're dealing with wind farms is called an embedment anchor. Imagine a spade with a chain. It connects to the turbines, about 3 of them per turbine. It can punch through 120 kilopascal sediments if they're less than 3 meters thick. If it's greater than 3 meters thick, you have to do a different foundation solution, a more expensive solution. That's something we need to work with the engineers, designers to understand what's important to them. This is where soil province map comes in. There's an example of the East Rampion offshore wind farm east of Isle of Wight that we worked on a few years back now. And you've got sands in the west left there, chalk on the east, and essentially you can quickly identify and show the engineers where we can put embedment anchors in the soft sediment or where we need to do drilled or grouted solutions in the chalk there. Working out what's important to them, and then showing it on a map where we can perhaps they can design the layout and what foundation solutions they might be using. And how do we communicate this? How do you get this across? It's working out what's essential and what's nice to have. How I like to do this, essentially, for a ground model, what investigation do we need to understand our ground model a bit better? Detailed design, what parameters do we need to understand our foundations? What's needed to understand that? And construction risk. What can we do now to work out the health and safety of the future when we start building these structures? And it comes down to a ground investigation risk register, essentially highlighting based on severity, consequence, and likelihood, costs on the cost, program design, essentially making it pop out what are the showstoppers for our sites, and just making sure we can overcome these early on rather than getting at that last minute stage and having to deal with it then. Once a wind farm's been made, it will last up to 25 years. And we don't always appreciate how it's got there in the first place. Going back to John's quote, it's about recommending the right course of action, paying the right amount of money to get the desired outcomes. And it's through a design-led ground model where we as geologists can recommend the right course of action, highlight those risks early on, and open up the communication pathways with the engineers, developers, designers to essentially ensure our site is a success and not a failure. And this is essentially the final product, the 3D ground model that we use to present to the engineers, and yes, very much the very final product. Thank you very much.
I believe our next presenter is coming in online again. Nicole, are you online?
Yeah, I'm here. It's working. There we go. I'll share my screen now. Here we go.
Yeah, we can see that.
Fab. Is that sharing okay?
Yeah, we can see that.
Fabulous. So, there we go. Today I'm going to be talking to you about geotechnical challenges and solutions for offshore farm. And to do this, I'm going to
Oh, there you go. That's
delve into. Oh, am I still here?
Yeah, I was just going to get you to show your slides properly, but they're coming up now.
Seem to be having some issues.
It's okay. Do you want to just try and share your screen again?
I can just share this.
There should be another.
Why is this not working?
You might be able to change your display settings if that helps.
Standard.
Yeah, there we go. That's
Is that
perfect.
working?
Yeah, we can
Fabulous.
see that. Thanks.
So start again. So today I'm going to talk to you about geotechnical challenges and solutions for offshore wind farm infrastructure. And to do this, I'm going to delve into a case study that I've had the pleasure of working on since 2023. But for client confidentiality reasons, I won't be able to disclose the exact site. So a little bit about me. I was born and raised in Chihuahua in Mexico for 3 years before moving to Liverpool in the UK. And I completed a geology degree at the University of Liverpool and then finished with my master's and graduated in 2023. I then joined Geotech Consultants in Manchester as an early career geologist, and since then I've gained about 1.5 years of industry experience, including hydrogeology, contaminated land, and geotechnical assessments. So in this talk, I'm going to discuss the UK's energy transition and the offshore wind infrastructure requirements. And then I'm going to delve into this case study and talk a little bit about the ground model, some challenges and solutions that we implemented, and then I'll close the talk out with a short summary. So here is a historic map of the coal-fired power stations in the UK. And in the 19th century, the UK was heavily dependent on coal for electricity generation, and it actually made up about 90% of the energy mix. In 1970s, however, the discovery of the North Sea oil and gas diversified the energy mix. However, the UK was still heavily dependent on fossil fuels. In September of 30th of September of last year, Ratcliffe-on-Soar actually, the last coal-fired power station in the UK, desynced from the national grid, and that marked the end of 142 years of coal-fired electricity generation in the UK. And that shows the progress that we've made towards the government set target of 100% clean electricity by 2030. And one of the key contributors towards this target is actually wind energy. So wind energy contributed as little as 3% towards the energy mix in the year 2000. However, in 2024, wind energy contributed just over 30%, which is a massive growth. Renewables also generated over 50% of electricity per quarter last year, and that just shows the progress that we are making. Next slide. So why is wind energy so effective in the UK? Here we have a map, and this shows all of the offshore wind farms within UK waters. And that's because the UK is surrounded by shallow windy seas, and these are ideal conditions for offshore wind farms. Currently, the UK has 43 operational offshore wind farms, generating a total of 14.7 gigawatts of energy. And the government actually has a target to expand this to 50 gigawatts of energy by 2050. And we are well on our way to meet this. Currently, we have 8 gigawatts of offshore wind capacity currently under construction, with a further 9 gigawatts awarded in contracts. So it's important to know that offshore wind farms require complex infrastructure and engineering considerations, and that's where our industry comes into play. Here are just a few examples of the engineering considerations. So it's not just turbines, as many will believe. And one of the considerations is actually transmitting the electricity to the national grid. And that's where our case study comes into play, as this is where we had our primary role. So Geotech was commissioned for a 2-year ground investigation in 2023 and 2024. And this was both onshore and nearshore. And this was to against a 55-kilometer route along 22 key crossings, and that included railway, roads, rivers, and canals. So that really added to the complexity of the project. And my role specifically involved developing ground models and cross sections to summarize and highlight the geology and hydrogeology at each of these locations. I also had to interpret the borehole logs, in situ tests, and laboratory tests, and then come up with preliminary engineering solutions along with a geotechnical risk register. So here we have a brief summary of the geology that was encountered at the site. To summarize the table, the superficial deposits that we encountered were mid-ground and topsoil, followed by tidal flat deposits and glacial till deposits. And this was overlying bedrock stratum, which consisted of chalk, sandstone, and clay formations, all of which have very varying characteristics and different engineering properties. And they are relevant when considering the deeper foundation designs that were necessary because of the loose and soft nature of the superficial deposits. So we encountered 2 main challenges during this project. The first being data management and visualization. So due to the scale of the project, it composed of 225 exploratory holes, and that included boreholes, cone penetration tests, and trial pits, all of which becomes very difficult to manage the test results for each hole. So when wanting to interpret the results accurately, it becomes quite an issue. The second was material variability. So superficial deposits were extremely variable across the entire area and had vertical and lateral changes. And that meant that we had to be really careful in designing our ground models to make sure that we were producing the most conservative results. So here we have 2 examples. So in 2023, we actually completed all of the data management manually in Excel, and then the cross sections were drawn by hand and digitized in a software called Grapher, and that's seen on the left. Versus in 2024, we adopted a new strategy to try and reduce, I guess, the risk of human error, and we actually implemented a new data management software called OpenGround, and this helped us screen all of the exploratory holes and kind of summarize the results for each of the stratums. And that allowed us to computerize a geological model in Leapfrog. And this meant we could automate each of the sections for each of the crossings that we had to study. And this change in system doesn't just highlight the technological advancements, but a fundamental change in how we actually go about geotechnical engineering, because these new softwares allow us to harness large data sets and visualize complex geology with a much higher degree of certainty, and kind of removes human error and human bias, but also reduces timescales and project budgets. So the second challenge was material variability, and here the anticipated geological unit was the Fenland Formation for horizontal directional drilling, and this is a tidal flat deposit. And this came with many of its own geotechnical challenges because the Fenland Formation has a high degree of lateral and vertical variability in grain size, material strength, and organic content, and that all impacts the compressibility of the soils. There's also many compressible sands and a high water table, and we had these collapsible units along with geoenvironmental testing, which suggested we had aggressive ground chemistries and high sulfates, which would impact the concrete design class. And we also had CBR testing, which came back with unreliable results because we hit an initial firm crust. And all of this variability makes it really challenging to kind of determine how materials will behave under a stress and a load. And therefore it increases the design complexity massively as engineers need to design to the worst case scenario. And this variability can lead to unforeseen circumstances that may result in challenges during construction or the longevity of a structure. So yeah, it needs to be, these ground models need to be heavily considered to determine how to safely develop these temporary and permanent works. So to conclude, offshore wind farm projects represent the kind of resilient infrastructure that the UK needs to transition to these low carbon futures. And I think the approach that we developed in 2024 will become increasingly valuable as the UK continues within this field. But this project was also massively helpful for my professional development and really helped me improve my geotechnical knowledge and understanding. So I'd really like to thank the GeoSynTech team who are very patient with my learning. And yeah, thank you for listening. If there are any questions, then you can direct them towards my email.
Thanks, Nicole. That was great.
No worries, thank you.
Thanks for coming. Final talk of the evening is Chris. We will go through the AGM for 2025. There'll be a couple of bits and pieces, get to know about the group a little bit more. So yeah. Okay. So I'm just going to give a brief overview of the Early Career Network's year to date since we held the award last year. So I am the chair of the Early Career Network. I took over in 2024 last year. Since then, we've had quite a turnover. We've had a bit of a transition period. The previous chair was leading the group for about 5 years. And we've taken on, I think, 4 committee members in the last 12 months. So it has been quite a change. In September, the Early Career Network held its first public lecture, EDI and the Energy Transition. It was a really good event. We had an excellent turnout, and the Geologists themselves even said it was the best one they had, but I'm sure they weren't, boasting on our own behalf. We then in November attended the GSL Careers Day. Had a really good day, meeting lots of prospective geoscientists. And we intend to carry on doing that sort of in the next year and so forth. In December, we held our first social in person for, I think, at least 5 years. And the real intention is that we really promote in-person events such as these, because really it's these events that are really important for early career professionals in developing the softer skills that otherwise we might be losing. In February, we welcomed another 2 committee members, so Ellie and Lucy. Ellie's here today. Lucy, unfortunately, based in Scotland, couldn't make it. We also put together a sponsorship proposal. So it's a formal document that we're really trying to use to promote either sponsorship to fund events such as these. And again, a big thank you for SLR Consulting for agreeing to sponsor the event this year. And I do strongly advise that if you have employers or anyone you know, contacts that might be interested in engaging with early career scientists, there are various ways that you can do this. And if you contact us, I'm more than happy to share that pack. We also pulled together a member survey, again, to really try to understand what it is that early career geoscientists are wanting out of this group, but also out of wider GeoSoc. Because at the end of the day, we are here to try and, we are early career professionals as much as you are. We're here to try and gain some value in the fellowship that we're paying for, and to take that forward, hopefully into chartership with the society. To carry forward our merchandise, our growing merchandise, last year we had our lovely yellow banner created. We've taken that forward to designing some grain size cards. We actually have them here today. They are newly fresh off the print, I think about 2 weeks ago. Jocelyn has them, so take one today while you're here. It is worth it. And then finally, yes, the Early Career Award again this year. So that's our year to date. I'm now going to present on behalf of our Treasurer, Will, who couldn't be here today, the report in terms of finances as well. So we had a residual budget of approximately £836 at the end of May 2024. For context, we have £1,000 a year provided by the GeoSoc. That's to cover everything that we do. And the remaining budget was effectively only there because we had a sponsorship from the year before. With our socials and effectively with that sponsorship, we've had the flexibility to really push out things like merchandise material and to hold social events. And yeah, that's been quite useful. As of January, we were again sponsored £1,000 to run this event, and effectively all of that sponsorship has already been spent just by holding this one session, plus more, to be honest. So yeah, at the moment, as of the end of tonight, we're probably looking at having about £670 to get us through until well, at least January. So again, yeah, sponsorship for us is a key way of providing value back to you guys. I'm now going to hand over to my vice chair, Rachel, to take us through some other bits and pieces. Thanks.
Yeah, thank you, Dan. So I'm just going to sort of talk you through the committee. So as Dan mentioned, we've had quite a change since the last AGMs. We've actually had 5 new faces join the committee. So I am one of those faces. We did say goodbye since the last AGM to 2 of our committee members. That was Simon and Harriet. They've gone on to do Pastors New, and we wish them every success in that. So I joined the committee this year. Ellen's also joined, who's here tonight. I'm sure many of you met. Will, our new treasurer, is also relatively new on the committee. And then we've also got Ellie and Lucy, who've joined us as well. So it's an exciting time to be on committee at the moment. Lots of fresh faces, lots of fresh ideas. So yeah. Cool. So we also ran a membership survey in January of this year. This was, as sort of Dan mentioned, just to try and get a better idea of what our members want. It's really hard to define how many members we have sometimes, because obviously as we're early careers, people age out, I suppose, at the other side, although we haven't been running for that long. It's always about getting new people in. So I think our LinkedIn, I did write it down, I checked yesterday, so we've got 1,600 people on LinkedIn, whether they all identify as our members or not, but that's really fantastic to have. We did push this membership survey, so this went out in January. So initially we pushed it through our mailing list to see who opens their emails and who reads these sort of things. And then we did post it on LinkedIn as well to sort of try and get more responses. We had 22 responses, which was perhaps a little bit less than we thought we might get, but it's still a really good starting point. Is the survey still open? Or it is, so it's still open. So if people would like to kind of contribute their views, that would be really fantastic to sort of help guide us. So I'm just going to very quickly run through some of the key points. I appreciate there's a lot of pie graphs on here, so I won't dwell on them too much. But in kind of summary, so around 75% of our members are fellows of GeolSoc, which is great to see. So as we're kind of supported by GeolSoc, it's good that our members are also aligning to that. But as sort of Dan mentioned, we are like a free to join group. You don't have to be with GeolSoc, so you know we trying to be inclusive as we can. Our members really do represent all parts of the UK. Yeah, literally all parts of the UK, which is that top right graph. That is great for us. It means we've got a great outreach. Also, it is a challenge when it comes to organising in-person events. Where do we put them? So we're great to have Burlington House as a base, but we're very aware we need to kind of reach out to everybody. Also got Hong Kong in there, so maybe not all the way out to Hong Kong, but we do definitely include them, and it's great that they're really great supporters of the Early Careers Network in their regional group. Most of our members, I think it says 81%, as expected, are early careers. So it's good that we're targeting the people who we are setting out as our mission to target. In terms of chartership, it's about 50% are getting that experience phase of their chartership applications. We have got about 30% in there that haven't started. Everyone's on a different journey in terms of chartership. So it's something that we do try and support. And I'll kind of come on to it in the next slide, but it's just good to be aware of where our members actually are in their journey so we can give them the right support at the right time, essentially. And then finally, just on the membership survey, we asked our members, what do you want from us, essentially? The top thing that came out was workshops and training. So that was quite interesting to see actually people want access to stuff, but perhaps it's maybe tailored more towards early career, not mentorship, workshops and training. Mentorship did also come out as a thing that people were wanting. So it is something we're discussing, whether we try and set that up and create links between perhaps people who are chartered, mentoring people through that chartership process. So sort of is on our plates at the moment with discussing how we might do that. And yeah, information sessions, I think that's also relating to the chartership side of things. So I think it is sort of demystifying that process for people. It can be quite a challenge knowing how you even start that process. So that's good to see that we've got these numbers and these guidance from people who filled out the survey, so we can take this forward and we can plan this. In terms of the actual events that people wanted the ECN to organise, there was a sort of a even split between online and in-person stuff, so that's quite good to hear in the sense of when we've got such a large geographical area, at least people do want that in-person and online, and we can cater to that like we're doing tonight. We've got people joining us from Hong Kong on this live Zoom, so it's really great that we've been able to do that. So we'll keep that in mind going forward. One-day field trips also came out. I love a field trip, so hopefully we're going to try and organise some of them in the future. So yeah, stay tuned. And if you do want to fill in the survey, I think the link is still active on our LinkedIn, but you've also got a QR code here. Is the £10 voucher still a thing? Yeah, so we also got a £10 voucher to incentivise you to fill it out. It's just going to be drawn at random, so you've got to be in it to win it. And then just in terms of future events, so we haven't posted about this yet on our social media because we've been so focused on the Early Career Award, or have we? Okay, we're doing it. So on the 12th of June, we've got a cross-collaboration networking event. So this is up in Birmingham. It's going to be with ourselves, REMSOC, SOBRA, the IES. Have I missed anyone off? No, that's all of them. So it's going to be really great. So this is other early career groups, and we're going to be essentially doing a networking event in Birmingham on the 12th of June. All the details will be out soon. If you've not already seen them, they'll be in our newsletter, etc. So do consider coming along if you're interested in that. We're also going to be doing a webinar in June. I haven't seen this slide fully yet. We're doing a webinar in June. We've also got the ECN Summer Social that's going to be held in July. We've also doing the public lecture, same that we had last autumn. So when that comes this autumn, that should be a really great event. So do keep your eyes out for that. We're also hoping to run an introduction to publishing workshop or event. So that's sort of people in academic side of geoscience. So that might be interesting for some of you guys. Also, hopefully doing a photo competition and regional field trips. So you can use your grain size cards in your photos and then you can maybe win a prize. But if you'd like to collaborate, please get in touch with us because we are always on the hunt for new ideas. If you're able to help us with running any of these events, like please do get in touch because we'd love to take you up on that. And finally, are there any questions for the committee whilst we're here and present? If so, let me know. If not, you can always get in contact with us on our email or via social media. And I will hand back to Dan. He's running. So yeah, that's fine. So yeah, somebody's going to win the trophy tonight and judges will deliberate. Oh yeah. Oh great, okay. Yeah, well we can also push it for our like social medias as well and try and get more people as well. Okay. Thank you, yeah. Yeah. About 1,200 pound apparently, so it does go up quite a bit of people. Yeah.
Yes, have all of them right. It's fantastic. That is pretty. Yeah. Thank you. Right. Indeed. Cheers. Time. Thanks.
On the stage, yeah.
Stage, come on.
Well, if you could make sure you speak into the mic, and then everybody on the Zoom can hear you. Sorry, if you could speak into the mic.
Oh, sorry.
Sorry. Everyone online can hear you.
I would thought we were getting a photograph rather. I know where the mic is. Which are we doing first?
Let's do the photograph of the judges and then we'll.
Looks like I'm the winner, which is the early career, just a late award, yes.
We're inclusive.
Okay, I'm just going to say a few words. I'll start with wow. My goodness. I think back to one of my early presentations as a student, like some of the presenters today, and my best chum was in the audience sitting on the front row, and he said, I was sure you're going to thump me because my wrists and hands had tightened up so much in the nervousness of preparing. But today was quite different. We had 8 wonderful talks without exception. We learnt a lot about wind or how to plant it. We learnt a great deal about water and how it moves in systems, whether it lubricates rock or moves in and out of the marine to non-marine setting. We saw CO2, it too moving, instead of going in the atmosphere into the ground, and again, a couple of talks there. And then we got on to rock, and we saw lots of rock. We heard about coal, which is masquerading as, or coal waste, which is masquerading as pyramids. We saw the impact of drop stones falling from ancient glaciers. And we saw those tiny little minerals, zircons too, at microscopic level. It was actually pretty difficult to separate all those wonderful talks. And I think the three of us, Dipali, John, and another John, would like to thank every one of you. There are highlights in each of those talks, but we were unanimous in our deliberations. Delivery, outstanding. Content, wonderful. Creativity, there. Technical content, spot on. And accessibility. Harley said, I think my 14-year-old son would follow that and enjoy it. So there is but one winner. Elias, where are you?
Yes. Congratulations.
Congratulations to all, though. Thanks for a great evening.
I'm really glad you're here. Okay, that concludes the event. Thank you for everyone who tuned in online. Thank you especially to everyone who came in person. Appreciate it on a Wednesday night. Yeah, thanks very much and hope to see you all again next year. Jocelyn's just reminded me I forgot to tell you we're going to the pub, so I will remind everyone that we are going to the pub.
I think we've had to rebook because there's some issues with the Market Tavern.
Yes.
Correct, the Market Tavern, which is about a 10-minute walk away. But I'll be leaving with Charlotte, so if anybody does cancel and take them, you're more than welcome. Don't be rushed.
Fantastic. Thanks very much, everyone.